In this video, we will do practice problems on finding general solutions of second-order difference equations. First problem is yt minus 1 minus 6yt minus 2 equals to 0, and we know that y0 equals to 1 and y1 equals to 6. First, we find the auxiliary equation, which is z squared minus c minus 6 equals to 0. If we factorize this, we get z minus 3 times z plus 2 equals to 0. This means that the two solutions are z equals to 3 and z equals to negative 2. When the auxiliary equation has two solutions, the general solution to this difference equation is going to be yt equals to a times x1 in power of t plus b times x2 in power of t, in which x are the solutions to the auxiliary equation. So a times 3 in power of t plus b times negative 2 in power of t. And since we're given what does y0 and y1 equal to, we can find what do the constants a and b equal to. So we write, in case of the general solution, in case of y0, which is 1 equals to a plus b, since 3 and negative 2 are cancelled out by being in power of 0. This means that we can separate one variable b and equate it to 1 minus a. We write the same general solution for y1, which is 6 equals to 3a minus 2b. Now we plug in, instead of b, we write 1 minus a, which is 6 plus 2, and equals to 3a plus 2a, which is 8 equals to 5a, and we can find what is a equal to, which is 8 divided by 5. Now we put this into the other equation, so we find what is b equal to, which is 5 divided by 5 minus 8 divided by 5, which is negative 3 divided by 5, which equals to b. And now we can write the general solution, which is yt equals to 8 divided by 5 times 3t minus 3 divided by 5 times negative 2 in power of t. Now we will look at another example, which is going to be a non-homogeneous second-order difference equation. The equation follows as yt plus 7 times yt minus 1 plus 12 times yt minus 2 equals to 40. 40 is a k constant, so in this case we need to look for a time-independent solution where yt equals to y with a star for all t. Therefore, we acquire the equation of y star equals to k divided by 1 plus a1 plus a2, in which 1, a1, and a2 are all constants that are found within the difference equation. We replace these variables with numbers, where k equals to 40 divided by 1 plus 7 plus 12, which equals to 40 divided by 20, which is 2. Now we can find the auxiliary equation, which is z squared plus 7z plus 12 equals to 0. If we factorize this, we get z plus 3 times z plus 4 equals to 0, meaning that we have two solutions, which is z equals to negative 3 and z equals to negative 4. Now we write the general solution of yt equals to y star plus a times first x solution in power of t plus b times second x solution in power of t. Now we can replace it as 2 plus a times negative 3 in power of t plus b times negative 4 in power of t. We will now be looking at another example with the difference equation being yt minus 8 times yt minus 1 plus 16 times yt minus 2 equals to 0. We write the auxiliary equation of z squared minus 8z plus 16 equals to 0. We can use the discriminant in order to find out how many solutions does the auxiliary equation have. The discriminant formula is b squared minus 4ac for a quadratic equation, which in this case will be negative 8 squared, which is 64, minus 4 times 1 times 16, which equals to 0. This means that the auxiliary equation has one single solution, so we factorize the equation, which equals to parentheses z minus 4 squared equals to 0. This means that the solution z equals to 4, i.e. in the general formula alpha equals to 4. The general formula for the difference equation is yt equals to a times t times alpha in power of t plus b times alpha in power of t. We replace the variables that we know, which is a times t times 4 in power of t plus b times 4 in power of t. We can take out the 4 in power of t, parentheses a times t plus b. The constants a and b cannot be found since we're not given extra information. And another problem in which yt minus 7 times yt minus 1 plus 12 times yt minus 2 equals to 42. This is a non-homogeneous difference equation. First, we will find the auxiliary equation ignoring the 42. In this case, this is z squared minus 7z plus 12 equals to 0. If we factorize it, we have two solutions, and we write z minus 3 times z minus 4 equals to 0. This means that the solutions are z equals to 3 and z equals to 4. Now we need to find the time-independent solution of y star, which equals to constant k divided by 1 plus a1 plus a2. We put in the information, which is 42 is the constant k, plus 1 plus the constants in the difference equation, which is 7 and 12. 42 divided by 20, and that equals to 21 divided by 10. Now we can write the general equation, which is yt equals to the time-independent solution of y star plus a times first x solution in power of t plus b times the second solution x in power of t. We replace the information, which is 21 divided by 10 plus a times 3 in power of t plus b times 4 in power of t. And this is the final solution.